Hello everyone, welcome to this video where we are given O is the center of a circle. This is very important. Angle OAB is an obtuse angle. This is a very piece of important statement here. Radius is given as 6 cm and we are given area of a triangle 9 cm. And so at this point, right, since they give me area of a triangle, then at the back of Mr. Tan's mind, then I think of this formula. Okay, so given any triangle, if I know this length and I know this length, then this is the middle included angle C. Then I can easily find the area of a triangle using this formula. Okay? And because they give me 9 cm squared, so for part A, right, you will see Mr. Tan, okay, applying this formula to help us find the angle AOB. But the AOB need to be in terms of pi and also in terms of radians. Well, another important thing before we move on to solve part A is that since I know angle AOB is an obtuse angle, at this point, right, it is useful to also know that pi radian 180 degree is equals to pi radian. Obtuse angle is any angle between more than 90 but less than 180, right? So of course I want to know what is my 90 degree. Then you will see that I divide by 2, so I'm going to divide by 2 and I'm going to have pi divided by 2 radian. So this is something for us to take note of, okay, which is, if you really want to know, it is about 1.571 radian to 4 SF. So this is something useful, okay? Now back to here, later then I'll come back to here. Now for part A then, they give me area of a triangle. 9 cm. And I know I have this 6 and 6. And they asked me to find this angle AOB. Alright, so at this point, right, let's take a look. You will then see Mr. Tan applying the area of the triangle out, half times A times B times sine of angle C, meaning in this case, half times 6 times 6 times the sine of angle AOB equals to 9. They give me 9. Then let's zoom into the working. Alright. Half times 6 squared is my 18. So I still have 18 times sine of angle AOB equals to 9. And I divide 18 on both sides. So eventually I'll get sine AOB equals to half. So to find angle AOB, I will have to do this step. Find the inverse, sine inverse of half. On your calculator now, you will get 30 degree. But, going back to the question, right? They actually tell me that angle AOB is an obtuse angle and it is at this point in time. Mr. Tan, remember, every time we have a sine ratio, here sine of angle AOB equals to half, there can be two possible answers. It's either the acute or the obtuse angle. In this case, 180 minus 30, 150 degrees. So right, if you press your calculator, sine 150 degree, so this is something to take note. Sine of 150 degree is also equals to half. Sine 30 is also equals to half. So right, there are two possible answers, out of which, in this case, sine 150 degrees, the 150 degree is the angle we are looking for because it is the obtuse angle that we are looking for, and the last part, they want it to be in radian. So I have to come back to my conversion again, starting with this. I know 180 degree, so my conversion is somewhere here as part of the working. Is pi radian. So 1 degree will be equals to pi divided by 180. So 150 degree will then see this. But then you will have to see what is 150 over 180. You will get 5 pi over 6. Or you can also write 5 over 6 pi. Both is fine. And that will be my angle, obtuse angle AOB. So do write your final answer neatly. Obtuse angle AOB is therefore equals to 5 over 6 pi radian. And that will be for part A. Part B, they would want to find the area of the shaded region. So at this point, I'm going to just bring out this again. They want to find the area of the shaded region. Will be good for you to see that we already have the triangle area, which is 9 cm square. So, if I know the sector area, which is this, the whole sector, how do you think we can find this segment? Yes, the green sector area minus away the black triangle, and I get my red shaded region. Yes, and that is where we are looking for, because now we know the angle in radians. We know this angle, 5 over 6 pi radian. So perhaps it is time for us to just recap our memory. Area of a sector, when angle is in radian, is half times r squared times the angle. So you will see Mr. Tan applying that here, where I will have my green color, half r squared theta. This is the green color area. Minus away my triangle to give me my red color area of this segment, and this is the answer in 3SF. And part C, where they want to find the arc AQB. So perhaps it is at this point that I'm going to pull out the diagram again. So for part C, right, they want this arc, and I already know this angle is 5/6 pi. Now the question is, what is this angle then? So please remember again, pi radian or 180 degree is equals to pi radian. What is 360 degree? Yes, 2 pi. And 2 pi is the whole thing. So this, I will have 2 pi minus 5/6 pi. Okay? And so, the next thing to remember also, arc length is equals to r times theta in situation where the angles is given in radian, and this is what we are having here. So here you will then see Mr. Tan's working is pretty straightforward. Radius is 6. The angle we are talking here is 2 pi minus 5/6 pi. And there it is. That's the answer. 22.0 cm to 3 SF. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.